Hello. Tonight we are going to be looking at solving systems only by substitution. Take out your MJ. We're going to be starting with a new page, and you can title it Solving Systems with Substitution. We're going to take a look at this problem here. So far what we've looked at is equal values method. So what we would do if we had a system similar to this right here is that our first step is y equals. We have to change this second one so that it's also a y equals and it goes into here. So what we're going to have to do is first manipulate this first one by solving for y. Minus 3x minus 3x, and then you end up with 5y equals, and I like to put the x's first, minus 3x minus 13, and then we need to get rid of the 5, and so we divide by 5, divide by 5, divide by 5. You could have written it all the way across if you'd like to. Right here, this is going to be then y is equal to this fabulous equation of a minus 3/5 x minus 13/5. Well, goodness, that does not seem like a very fun equation. If I had to take this guy, then right here, see if I can highlight it, there we go, and put it equal to this one right here, to try and solve, take away the y. So I'd have negative x minus 7 equals negative 3/5 x minus 13/5. That just sounds like a little bit crazy. There must be another way, and there is. So let's take another look at this equation. Same problem, only we're going to try this thing called substitution. I should point out that this would still work if you were to put an equal sign in between these two. You'll still end up with the same answer. It's just going to be a little bit more ugly. Okay, let's do same problem, only now we're going to look at this thing called substitution. What I want to see is, if you look, I'm going to highlight this. If you know that y equals this whole thing right here, that's what y equals, why can't I then substitute it in right there for y? And that's essentially what we're going to do. If you know what y equals already, let's put it right in the second equation. So, looks something like this then. I now have, I'm going to take this equation here, and I'm going to rewrite it as 5 times, now this is this y right here, and I'm going to put it right in for y. 5 times, whoops, negative x minus 7. And now I can just continue the rest of the equation. Plus 3x equals minus 13. And so what I essentially did was I took away this y, and instead of writing y, I wrote what this equation was. And now it's just as a matter of solving for x in this case. So I get 5 times negative x, 5 times negative 7, negative 5x, plus 35, plus 3x is equal to negative 13. And then I am going to combine my like terms, minus 5x plus 3x. I have a minus 2x plus 35 is equal to negative 13. And subtract 35 minus 35. And I'm left with minus 2x is equal to a minus 48. And final step, divide by 2, negative 2, divide by negative 2, and therefore we get a much nicer equation to solve x equals 24. Okay, now if we would have gone back to our first equation, even with this fraction here, we would have gotten the same answer for x. You can go ahead and solve that. I won't do that right now, but you should still get 24. Once you get the 24, don't forget to then substitute it back into the equation if you know what x is. Then you go ahead, put it back up in for x. And so I now have y equals a minus 24 minus 7, y equals a minus 31. My final answer then, rewrite it as a coordinate, is going to be 24, comma, negative 31. So with substitution, essentially, there's going to be a variable that we can just substitute in this case it was y. If you look at the next couple problems, here's two more that you can try. I won't do them at this moment, but I'll kind of lead you into it. In this first equation here is that you know what x equals, so let's go ahead and substitute this whole chunk in for x this time. On our first equation, we knew what y equals. That was the variable that was by itself. It was isolated. In this case, we have an x that's already isolated, so we could substitute it in. You'd first solve for y. Over here is the answer. You'd end up with 2. Substitute it back in, solve for x, and you end up with 2 again. So give this one a shot. We'll practice some more of this tomorrow. You should end up with 2, 2 for this equation. The second example down here is you'll notice the second one definitely looks a little bit more complicated than the first one. But neither of them have just an x equals or a y equals. So in this case, you're going to have to just do one quick step of manipulation with this equation here. And you could either do x is equal to 9 minus y if you solve for x, or y is equal to 9 minus x. Now that you have this, you can go ahead and substitute in for either x or for y, depending on which one you did. Again, here's your answer right here, 7, 2, if you were to go ahead and solve that. We will practice some more of these tomorrow in class. Be sure to bring your notes. Have a great evening.